Good morning, everyone. Welcome to Ona Highlight. I also want to thank audiences on Zoom, online attendees. Thanks, everyone, and it's a pleasure to be here. I introduce myself. My name is Golmar Golmohammadi. I'm a faculty member of the Department of Soil, Water, and Ecosystem Sciences, and I'm based here at RC-REC at ONA. My specialty is watershed hydrology and AI application in environmental systems. And the research that I'm presenting today, flood susceptibility mapping in Florida, is part of a broader research that we do in our lab, where we integrate the physically based modeling with AI-enabled geospatial models to research, to study the environmental risks like flood. Before I start, I would like to acknowledge the hard work of my team, my graduate students. They are present here: Saba, Namrata, Gurjoban, Arman, and my researchers, Akil and Baban, and my previous graduate student who contributed. They all contributed to this research, Sayed, Mustafa, Biazar. So let's look at this flood susceptibility mapping. Flooding can be studied in different ways. It can be, some approaches are looking at the event-based floodings like hurricane. It's just, for example, mapping inundation during the hurricane. Other studies, they focus on the forecasting and how we can predict flood in for future. And there is a third perspective, which is focusing on long-term spatial patterns, identifying which areas actually are consistently prone to flooding. And here in this talk today, I focus on the third perspective, which is understanding flood susceptibility or risk across the landscape in the state of Florida. This is a statewide study. What is the research about? Let's see, what is this research, or what is flood susceptibility about? And why does it matter? Why it's important? What does it do? It's actually, instead of focusing on a single event like hurricane, this research, flood susceptibility mapping, it answers a different question. It's just looking at where does flooding tends to happen repeatedly across the landscape. This research, when we generate the flood susceptibility map, it identifies the areas which are more likely to flood repeatedly by time. It also, this type of information is important because they represent long-term landscape controls, like the important factors like soil, drainage, and elevation. Those are the ones representing this research. So the goal of this study is to develop an accurate and interpretable statewide flood risk map, which is reliable for the state of Florida. In Florida, we know that flooding directly affect how we manage the lands in Florida, especially in the ranch lands in the southern part of the state. We are doing some experiment and some studies here. So I'm talking about like how it could possibly impact the managing the ranch land. One of the biggest challenges is access to the ranch. When the flood happens, we often cannot reach to the sites where we want to go for any type of work, or like farm work or research or planting. It also impacts infrastructures. It could, like roads and fence and water controls could be impacted. And ultimately, it introduces uncertainty and economic losses to the ranch system. Here, in this slide, I summarize the overall framework of our research. Let's start with the first, with the left part of this slide. You can see the data are listed here. So inputs are used in, these inputs are like the flood triggering factors, as well as the FEMA National Flood Hazard Zones, which is the inventory map based on the observations. We have this map. So then we use the AI methods to model them. Different type of methods has been used. And as part of this study, part of these machine learning models, after using the model and predicting, we have also looked at the important factors. So it's not only predicting, it's also, we are looking at which factors has had the most impact on the flood risk in each pixel or each area in each region. So we didn't stop here. We also looked at in parallel, we used the satellite data to observe the surface water dynamics, which help us to interpret how flooding actually happen across the landscape in Florida. We also integrated hydrologic and hydraulic modeling to further contribute to the interpretability of machine learning, which is a challenge in terms of AI models. So overall, this framework integrates data-driven modeling, Earth observation, and process-based understanding based on the modeling work that we are conducting there to produce both prediction and interpretation. Let me briefly describe the data and pre-processing workflow. We start with a statewide flood inventory map, as I explained here, and you see the map on like the left part of this slide, and also the data, the input data, which is like different type of triggering factors of the flood as images. In addition, we compile actually a set of environmental and landscape factors, including like these data, which are shown here, include topography, soil, landscape, and other factors that are important to flood to happen. So these data sets, like we went through the data pre-processing, then after that, like in summary, we have, after collecting the data, we have looked at the, actually we prepared the data, pre-processed it, we harmonized it, standardized the data, cleaning the gap and normalization. And after all of that, we had like stacked all the input data in a format that we can enter to the machine learning models. So then finally, this data set is divided into smaller tiles as I presented here, and those are the inputs that we enter to the models to be able to develop the flood susceptibility map. So we use two different models, an original CNN model and also a deeper ResNet 50 model. Those are both machine learning models that we used, and the inputs to these models, as I said, was the stacked pixels, which like we created stacked conditioning factors, which representing the multi-channel raster data we created. And then this model learns like how we did it in general. Like if I want to say how the model has worked to generate the flood susceptibility map, the model learns nonlinear relationship between the environmental factors and historical flood occurrence. And the final output was a continuous flood susceptibility probability map across the landscape of Florida. And here's the results that you see. On the left side is the statewide flood risk map, which highlights the areas with low, moderate, and high likelihood of flooding. And you can see a strong spatial pattern in low-lying and poorly drained areas. And this map, which I'm showing, is the best model, which was ResNet. So we generated the ResNet and CNN maps, but we selected the best model and presenting here. On the right, I show the key drivers of flooding, which is the most important factors, which include rainfall, drainage, wetland, and other factors. We rank them. Those are the ones had the most impact on basically how the land is susceptible to flood. So this is important because it shows that the model is not only like, we will see these factors which are like ranked, like that makes sense somehow, like rainfall is the most important thing, and then drainage, and then wetland. That shows us like the model, it's not only predictive, but also physically meaningful and interpretable. So the key question here is, do these patterns actually appear in reality? In the other word, do high susceptible area consistently show up as surface water on the land if we look at it? So to answer this question, we used satellite imagery data to detect surface water and then to aggregate it over the wet season, which we generated a surface water frequency map for the area, one area, which we selected here. So the area we selected are shown in this map. This study area is intentionally selected. It was important for us to work on this area and analyze the satellite imagery in this area because we have a well-established hydrologic monitoring network there, and along with actually current modeling work going on there. So we chose this area because we have a good understanding about the system physically. This allows us to interpret the satellite observation in a meaningful way. And this provides a bridge between the susceptibility model that I showed you, actually the map, and the real world hydrologic behavior. So these are then I talked about, like, we are familiar to the area. We have like monitoring network, including flow, groundwater, surface water. We are monitoring and we know, and also we are modeling that area. That's what like I was talking about. From field observation and also from the experience that we have there, we know that flooding tends to happen repeatedly, almost always in the same areas. During the last few years, we had like, there are certain areas we know actually when we go there, it's flooded. And the question is whether we can capture and quantify that same persistence using the satellite imagery. And this is exactly what seasonal surface water analysis, which I'm going to show you in a few minutes, is gonna, in the next slide, allows us to test. Now we have generated the seasonal flood maps, and I'm showing here in this slide. On the left side, the first panel, you will see, this is the first panel you see is the flood susceptibility map for that selected area. And the next three panels next to it, they are the seasonal surface water frequency for those for the consecutive years of 2023 to 2025. And each seasonal map, it shows how often surface water was observed during the wet season. And it's called the aggregated map or water frequency map of the area. And even visually, if I zoom in, or like maybe you would be able to see it, that some areas repeatedly show higher water persistence, and these patterns correspond well with the susceptibility map. And on the right side, I summarized here in this plot actually the comparison between the flood susceptibility map and what we can see on the land using the Earth observation and satellite imagery, the analysis. So I calculated the percentage of the pixels that falls into the low, moderate, and high susceptibility classes for each year, like wet season of 2023, 2024, and 2025. And what we observe here is relatively stable structure across the years. So even though the wetness impact the changes, and you will see the wetness changes like when you go to the land changes from year to year, but the overall distribution across the susceptibility classes, it remains fairly consistent. And that is the key message. The susceptibility map, we can say, it's not just producing a spatial pattern by itself. It is capturing persistent signal in the landscape. Alongside the susceptibility mapping and the analysis that we have done, we also developing a hydrodynamic model for this study area, which is, this is the DeLuca area and the watersheds around it. So we used a model called Mike, and one important thing that I wanted to share with you here, that's why I have this slide, is about sensitivity analysis of the model. When we analyze the model, based on the different factors and the sensitivity analysis, we found that hydraulic conveyance, roughness, and storage, and surface and subsurface exchange, those are the most important and most sensitive. The model found to be most sensitive to those factors. And from the other hand, based on the AI approach, and when we look at the interpretability, we found that drainage, connectivity, topographic wetness index, and wetlands, again, those are the important factors in order to just generate, actually, in order to the area that are susceptible to flood. So then this alignment gives us confidence, like a level of confidence that the susceptibility patterns that we have is not statistical only, but it reflects the underlying hydrologic process of the system. And moving forward, the goal of this study is that like it's going to that direction, like to integrate these two perspectives as the modeling work continues. So we have both data-driven and physics-based evidence pointing to consistent flood drivers. And the natural next question that we want to answer is, how can we actually use the information in practice? This is where the work becomes practical. The susceptibility map is not just showing patterns, it's also help answer real management questions. Like when we use these maps, for example, where should we avoid, like we can see where should we avoid doing like different practices, like including grazing management or like any farming practice. It helps to generally where areas are likely cause repeated access issue, we can see using this map. And also it can support decisions on infrastructure such as where to place road, fences, and water control features. More broadly, it helps prioritize area for drainage and our proposed BMP practices. So the goal here is not just mapping, it's like also supporting better, more informed decision-making on the ground. To summarize this work, I could say it shows that flood susceptibility mapping captures persistent landscape controls on flooding. The susceptibility mapping also captures those underlying controls where the EO data of Earth observation shows how they express under real hydrologic conditions. It also shows that we also see the consistency across years and agreement between the data-driven and physically based models. And ultimately, this work, this is where it becomes useful. These maps can support better planning, reduce operational risk, and improve decision-making in agriculture system. So here I want to thank you again, my team members, all the graduate students and researchers here at Watershed Hydrology Lab at RCREG at ONA. And thank you all for your attention. And here I take questions.
I'm sorry that you can't see that, but the next Ona Highlight is going to be on May 12th, and that is with guest presenters Lindsay Crum, a UF multi-county livestock extension agent down south, and Dr. Carrie Minter, associate professor of biological control of invasive plants, and they're going to be presenting training the next generation of agricultural professionals while bringing doom to the whitehead broom. So that is, again, going to be on the 12th of May. And as I always do, whenever I send you the recording for today's Ona Highlight, I will share this information again with you, this and the events that I'm about to tell you about, along with those flyers and the links to register, if there is a link, just in case you might be interested in participating. This event is going to be held tomorrow at the Okeechobee Livestock Auction Market. And it's their Cattlemen's Roundtable that is provided by UF IFAS Extension, Lauren Butler. Dr. Sellers is going to be there to discuss with you all weed control in pastures. There is no registration for this event, and it is free to attend. So check it out if you can. And again, that's at the Okeechobee Livestock Market at 11 a.m. The 75th annual Florida Beef Cattle Short Course is coming up. That event is held in Gainesville, and it's going to be Wednesday, the 29th, and Thursday, the 30th of April. I know the print there is kind of small, so as I mentioned, I will be sharing this flyer with you. For the center, we have Dr. Sellers speaking on Thursday, and he's going to be talking about control of Brunswick grass and other invasives. Newly announced, the South Florida Beef Forage program is going to be offering their herd health seminar on May 26th at the Arcadia Stockyard, in Arcadia. And that program is an evening program from 5:30 to 8 p.m. Registration, I believe, is somewhere I think it's $10. Yep, $10 registration fee, and your registration is on Eventbrite. Also coming up is our Youth Field Day. That event is scheduled for June the 11th here at the center. And I'll also share this flyer so you can have all the details. This year's classes are going to be discussing the basics of female cattle reproduction, tracking animals with telemetry, smart technologies for ranch water, from pasture to plate, understanding beef cuts and meat basics, and the New World Screwworm. Aside from those informational classes, there's a morning learning expo that's full of wonderful booths from different things like different colleges to weed control to hydrology and all kinds of different topics revolving around beef cattle and land. And it's an awesome event. Highly recommend it if you've never attended with your children. And if you do not have children, share this with somebody that you know. Students come from all over the state to visit the center for this event. If you don't already do so, we highly recommend for you to follow us on social media. We're on Facebook, Twitter. We have a really active YouTube channel as well as Instagram. And then if you do not receive our newsy emails on Friday, send me an email to the email address you see on your screen, and I'll sign you up. So every Friday, you'll get a little bit of news from us, happenings, things that we're doing, things that are coming up, events that you might be interested in. So again, I hope that you are able to join us in May and be watching for the email for the recording of this event. Thank you for joining us. And there are no more questions. But if you guys have any questions, just reach out to Dr. Golmohammadi, and she will get back to you to help you with your questions.